Hello, and welcome to the Professor Podcast with Ruth and Claire. Each episode, we talk about a particular topic in the life of a professor. We are tenure-track faculty members in the sciences, working at a primarily undergraduate university in California. The purpose of our podcast is reflection, so we bring something we think is working and something we're working on to discuss.
Welcome to the Professor Podcast with Ruth and Claire. I'm Ruth.
And I'm Claire. And today we're talking about utility value. But first, Ruth, how was your week?
My week was a funny week. I was just really out of sorts all week. Super. And I feel like I've talked to a few people who had a similar, I don't know what's in the air or whatever, but just like on Tuesday, I was sure it was Wednesday and just all, I think partly the kids, some kids in my kids' class have gone back
to face-to-face school.
Yeah. And ours aren't, but their whole schedule has changed. Like all their meetings, and I didn't realize how much I was doing kind of on autopilot. And so
that makes sense. So, sure. Yeah.
Yeah. So I just was super, and the kids were like, but isn't it Friday? And I was like, no, it's only Wednesday. It was just a lot of, everybody being a bit like out of sorts. So not like terribly grumpy, but just discombobulated. So
I can totally, I mean, at the beginning of every semester, it takes a while to be like, wait, what is my Wednesday schedule like? So I'm not surprised you got thrown off, all of you, by having a different schedule.
Right. And we had, I'm part of a project that had like a site meeting. I'm doing like whatever, inverted
air
commas
quotes?
For that bit, or air quotes, that's what it is, for something. And so, I just was constantly surprised by all of those meetings. Like, it's like, oh, it's happening in 10 minutes. And it was just, not my smoothest week, but not terrible either. But tell me, how about yours?
My week was good. I had a moment of, we had face-to-face classes for the first time last week. And the week before, my student assistant and I came in and checked everything. And we're like, okay, all the instruments are working. Everything's great. And then the day that they went to use one of the instruments, well, 2 of the 3 worked great, but then the other one, the computer just wouldn't turn on.
Oh.
The instrument was fine, but the computer... So anyway, it was fine. The students who were supposed to work on that made all their solutions and then just saved them. But it was kind of a panic thing. Like, I'm not a computer person. I don't really know how to turn them on. But the story that I want to tell is of other people coming to the rescue and saving the day. And so the next day, these 2 wonderful people, Lewis and Tyler from your physics stockroom.
An actual walking saint, but
Yes. So he and Lewis came down, spent like hours working on this computer issue. And anyway, it's working now. So they completely saved the day, and it was wonderful. So it was a good reminder of working with people and other people being able to save the day, and it being so nice.
Dude, that's something I actually really miss about, like, being in work. And I'm thinking of Tyler in particular, actually, because he like saves the day about 50 times a week for me. Like, where like, I can't get this thing to work, and he's just super calm and helpful, and just those kind of moments of just kindness and people just being kind of amazing and giving up their time.
Yes.
But I feel for you though, because like I was thinking, we just don't have like the flexibility, like, because I was thinking, our computers regularly don't work in the physics lab, and you just tell people to pile up together and all be on the same computer. And I guess you can't do that right now, right? And it's like, it's just a different kind of parameters that you have to solve problems. So
totally. Yeah. Mm-hmm. And I'm not on campus as much, and so just coordinating with people, but it all worked out because they were so willing to jump up and save the day. So good reminder to work with people and help each other.
Yes.
So that was nice.
It is. And people are generally awesome.
Yeah, exactly.
So, wonderful. Good.
So do you have a quote for us today?
Yes, I do. I have a quote for you, and it is from the President of Ireland, Michael D. Higgins, who I have a very, very soft spot for. So in Ireland, the presidential role is like quite different than here.
Okay.
Like, it's more separate from the government and more kind of like a figurehead and someone who's sort of representing the country, but not necessarily making political decisions about things. And so he's a poet, and I actually met him on the night he got elected when I had gone to vote for him. And me and my eldest daughter was like only like a few months old, and she was in a little pouch and I ran it, like him and his wife were outside just
Wow.
like chatting, and it was just super random that like my daughter gets very excited to tell people that like she knows the president of Ireland. It's like,
That's
yeah.
awesome.
So yeah, and then the other reason I love him is a lot of people have made tea cozies of him, and it's always called like Michael T. Higgins, and they're like these super adorable tea cozies of him. You know, it's all good,
That's
all
great.
good things. So the quote I have from him is, "The reconnection of society, economy and ethics is a project we cannot postpone." And I think that is super relevant right now. And
What
I
were
think
the
even
three? Society,
economy and ethics.
society, economy, and ethics. Cool.
Yeah. And I think it's super relevant for like thinking about like the crucialness, say, of like maybe the ethics of making sure people have paid sick leave. It is actually very pragmatic in a time like now when we don't want people to come to work sick, or, you know, like all of those
Right.
things, or who gets vaccines, like countries. It's not really just a moral decision. It's really crucial for everybody's, you know, anyway. So all of these things I think are sort of thought of as being separate, but they all need to be not separate.
Connected. Yeah. That's
Yeah.
really cool.
So yeah. So anyway, and if you want to cheer yourself up, look up Michael T. Higgins.
Nice.
Patterns,
Okay.
because they're super cute. But yeah. Okay, so today we are talking about utility value,
Yes. And this was a new term for me. So
and it
will
was
you tell us
only
what it
like
means?
3 days less of a new term for me. So,
Okay.
yeah, but so it's kind of, I think I've mentioned on here that I'm doing a course in culturally responsive STEM teaching with Escala. And they talked about utility value, which is convincing students basically of the usefulness of whatever it is you're doing, such as a lab or problem solving, you know, assignment or whatever it is. And they really frame it in terms of how the response for students, they talk about two types of learners, and one type is high context and one type is low context. And in general STEM disciplines, the sort of traditional way we would view them would be low context. So kind of things like just want the piece of information that's relevant, or learning for the sake of learning, and a lot more kind of individualistic, which is not necessarily bad at all.
Okay.
Whereas high context learners are more like, how does this relate to me and my life and my community, you know, that kind of thing, and taking in information in a less sort of linear, direct fashion.
Okay.
And the kind of argument they were making is that I think utility value is important for everybody and it enhances everyone's experience, but particularly for learners who are more high context and maybe coming from situations where they really, you know, are concerned with like, how will this help me get a job, or how is this relevant for my community or my family, and that sort of thing. And so they were talking about some papers that showed, you know, kind of explicitly stating the utility value, or like convincing students of the usefulness of things, had an impact on some of the kind of grade disparities that can happen in different demographics. And so it was super interesting to me, and yeah, I was very excited about it.
That's really cool. That's really cool. So I read through the information that you sent me on it, and I just wanted to mention, so one of the things that popped out to me was there was a part that had a few different phrases that one could say as a teacher that would help convey the utility of the information that you're talking about. And those phrases kind of stood out to me, so I wondered if I could just jump off by saying some of those phrases.
Do it, yeah, totally.
As kind of, this is kind of like, so some of the phrases are like, this process is enjoyable because, and you explain, you know, why you might enjoy doing the things we're doing, or saying explicitly, you are making progress towards expertise in this way. You can make sense of this info by connecting it to what we talked about last week, or this is relevant to XYZ thing in the community. And so, I guess I'm new to the term utility value, but I do try to do a lot of these things a lot. And so I guess what's working for me is remembering to be explicit about why this material might be interesting or relevant to the students. So, in the context of analytical chemistry, rather than just saying, here's another analytical method, I might say, the benefit of this method compared to the one we talked about last week is it can measure lower concentrations, which means we can use it for things like measuring arsenic in drinking water and making sure it's not toxic. Or, for example, in my research, we use it for XYZ and trying to give more context. So I'm I'm hoping that those kind of things fit into this utility value. And anyway, it was really interesting to read those example phrases of.
Well, that's super interesting because as part of our tenure process, we observed each other's classes. And I remember commenting specifically that I didn't know it was called utility value, but you do a really great job of this. And like, you spent a lot of time at the beginning of the lecture really motivating why this was interesting. And you actually did explicitly that when you were talking about like a new measurement, like an instrument. Cool. And you were like really connecting it to how does this compare to this other instrument. And then you had a separate thing that was all about like why we care about water quality and how this works. So it's actually...
How funny that I
Yeah, so,
did that
and I
exactly.
remember being like, oh, she did such a great job of connecting those things. So that's really interesting that... Sometimes it's funny when you have a thing that you do and then now it has a name and you're like, oh, that's the thing I do.
Yeah,
so
totally.
Yeah, I think that's excellent.
So what else do you have to say about utility value? What's working for you with utility value?
So I think for me, like on my side of things, I think especially the class I'm teaching right now, I very strongly believe in the utility of everything I do.
Oh, great. That's awesome.
And certainly when I first started teaching, I hope no one who took my class then, like I was just like, oh, we do this workbook page because I need something to do for this class period, but at this point now I'm very much like, no, question 4 really gets to the point that they'll forget that the initial velocity isn't always 0, or like there's I have that sort of in my head really like connected, and I really am solid on all of that. And I think I do hopefully a good job of like the enjoyment piece, kind of creating like, I don't think I really mentioned this with the utility value, but just like even the utility of it can be because it's enjoyable and you're building camaraderie with your classmates and that sort of thing. And I have a few examples that like I think I've mentioned on here, like a problem for projectile motion that's like a clip from the movie The Matrix, and then another one from a movie Deadpool, which I haven't actually seen, but it's like this that was inspired by something someone said at a conference, so we do a lab based on that. And those kind of things that are actually like connecting what you do to the outside world. And I really remember, did you see the movie Hidden Figures?
I don't think I did, but I know about it's the other people who contributed to the space launches and stuff like that, right?
And
yes.
I just had such a strong yearning because they had like the biggest chalkboards, like you needed a full-blown ladder to get up to those. Like, oh my God,
cool.
That would be so exciting. But they were covered with all these kinematic equations that really aren't that much more sophisticated than what we have. You know what I mean? And so I can remember a few students at the time being like, but they're the same equations. And I'm like, I know. And people went to the moon with those. And so that was super
That's
cool.
Awesome.
So, yeah.
That's some context. Gosh, this
totally
is useful if you're trying to figure out how to get to the moon. Those people that's awesome.
And I think like sometimes I do have a thing with students where there's always some students who maybe have a bit more experience, but they're like, why aren't we including drag, and why this and this, and kind of making the argument that we can actually do quite a bit, like make accurate predictions that we can see in the lab with these equations that aren't, they don't take into account everything, and yet they're pretty good models. So I think they're the things that I feel confident about, that I think I definitely earlier on would have like a couple of labs where I was like, fine, we have to have a lab about this, so this is it. But like I didn't really, you know what I mean? And now I feel more confident that my materials are useful.
So you yourself at this point feel like you understand the benefits of the different labs and the different different example questions, and all that really is crystallized in your head, and you see the utility of each one of those. Is that kind of what you're saying? That's awesome.
Yeah, my working on list is a bit longer, but but there's some stuff in the working on that anyway. I'll tell you. So tell me about you.
This is something that I actually proposed and got funded for, but have not yet done. And so I'm still not quite sure on how to do it, and I'm working on it, is making some reflection activities that are appropriate to analytical chemistry content, where the students connect the analytical chemistry content to some aspects that are valuable to them, such as the location where their family lives, or the food their household eats, or something, And And I think we've talked about this previously on the podcast of maybe they could write a letter to their 5-year-old brother explaining the lab that we just did. And so then they would think about what are the useful things that they could talk about in the context of explaining it to this 5-year-old. So I haven't figured out exactly what activities I would want to develop where it would, because my goal, of course, is that they're connecting the content to things of value to them while reflecting on the content and then understanding more deeply why they might care about the content. So that's kind of the goal. So trying to figure out, there's lots of ways that could go from that goal. And so I'm working on figuring out which way suits me best, and this class best.
Dude, I love that. That's that's so perfect. What a cool illustration of doing this.
Yeah, I'm excited to try it out. I was planning to try it out last semester, but then with everything going virtual, I didn't do it last semester, but I'm definitely going to do it next semester. So yeah, something, just a first go at trying to make some kind of reflection activities connecting the material. So yeah, I know that lots of people talk about writing letters to specific family members. I think I heard about that from you to begin with, or connecting it to a place. Talking about measuring water, maybe it's important the different water qualities in the different places, or maybe it's important what's in the different food that different people are eating, or, something more tangible.
Yeah, this is so trivial and so not something very important. But I really remember the area we lived in before had like the long drought for a long, long time. And my hair and skin was so dry. But I guess it's because there was so many minerals in the water because the water table was so low. And anyway, so not obviously life-changing for anyone, but I was like, oh, I wonder, could somebody that blew my mind, the whole concept of when the water table got so low, it would mean like this increase. Because we went through so many kettles as well. We didn't,
oh, really?
They
dissolved away?
Well, they just ended up with so much, the heating element. And we had a couple of electric kettles would just get eaten up. And so,
I see.
Yeah.
Interesting.
Yeah.
Yeah. Well, that's cool. It reminds me of whenever we talk about EDTA, which is this big molecule that binds metals. There's fun examples where EDTA is also in shampoo, because if you have hard water that has metals, it's hard to rinse out soap. But with the EDTA binds the metals and makes it easier to rinse out the soap. Or it's also in mayonnaise, because the things that might grow in mayonnaise that you don't want to grow in mayonnaise need metals as nutrients. And if you bind it with the EDTA, suddenly they don't have the metals available. And so then it's a preservative and the mayonnaise is fresh. And so anyway, those are fun examples.
That is super cool. And it's weird, this stuff, at one point in grad school, I was learning about polyelectrolytes. Is that what the word I'm looking for?
I'm not familiar with
they're long polymers that are charged, and so they kind of repel each other and sort of stand out more.
Okay.
But it was all about basically how if you put salt in, it will collapse them.
Okay.
And that's why your hair gel, if you go in the ocean, will completely just fall apart.
How interesting.
It's not. And yeah, that has stuck with me for 15 years. I'm like, ooh, that was so interesting.
So are these examples of utility value?
I think so. Don't you? I think making connections, and I think that it's so, at times, the way science has been taught, it's this is just interesting because it is interesting. Instead of,
you should care about these molecules, instead of being here's some connections.
Hair gel, And I think, and honestly, I think that physics is a bit more guilty of that in general. Just this should be interesting because it's just interesting, not necessarily look at the elegant math instead of, what it could do. Do you know what I mean?
Mm-hmm. Yeah.
And so, yeah.
Interesting. So what are you working on?
I'm working on, I think I don't always convey my conviction about the usefulness of all of these things. And I think I had an experience where, so I recently did this matrix assignment with the students, and it's kind of funny because at first when I did it, I was like, oh, check out my cool points. And then they don't know what this movie, they're this old movie. They're none of them have seen it. So it's not as, hot topic as I think it is. But anyway,
the Matrix is old to them, so they're not.
They're so, and to me, it was the most mind-blowing, biggest event of my undergraduate life was this movie, and they're just what is this old-time movie? And so it was funny.
That's funny.
And then I did this Escala workshop, and then I went to lab that afternoon on Zoom, and I kind of was prompted to have a whole discussion with them about why we do labs. And that, you know, there's sort of people say kind of briefly like hands-on experience, but like, what does that mean? And especially now that we're doing them as simulations. And I was talking to them about how it's all about getting information in a different package. So, you know, like in physics problems, I could either just give you a list of variables, like V is equal to blah, 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 and then you just plug them into equations. Or we do kind of context-rich problems where I'm like, Joe is walking to the store. He starts at rest. And you have to translate that into variables. And then like a third level would be doing something like a simulation or an experiment where you're actually like measuring the thing. And getting, so like, and so just talking to them about how that's another level of learning and understanding that if they can actually like do that, that's going to like enhance their abilities for problem solving and all of those things. And then like I didn't mention, but I told them later on about like the Matrix, somebody had to do those calculations to make that happen in the movie. And there is people whose job is like computer game simulations, or like they program in physics into computers so that they can create these environments. And this is like not any data at all, but I felt like they were more engaged with the lab right after that. And they were more, and it just felt like so, it's like one of those things where you're like, why don't I do this all the time? You know, and it's just like, I'm kind of, sometimes you're just on this like treadmill of just churning through things. And even at first when they introduced this idea of like motivating everything you're doing, I was like, well, that sounds like a lot of work, you know, like I don't want to, like, that's a lot of stuff, but it wasn't, it was only a few minutes. And I think I've talked a lot on here about struggling with conveying what does a physicist do as a job, you know, and this is like a perfect way to do that. Like, oh, someone has to make these simulations, or someone has to calculate whatever, how to get to the moon, or like those kind of things. So I think, you know, I think there's different levels in that. So there's just, this is useful to you because it will make you do better in this class. It's not, you know, like it will make you understand the material more, or this is useful to you because someday you might get a job doing something like this. And so, yeah, so I think the thing I'm working on is like just actually doing that. Instead of just like, fine, we're here, let's do the lab we have to do. Or, you know, maybe I can just try and motivate a little bit more, you know, why we're doing, I don't think I do a good job of explicitly saying, like, I think I have done a good job of having everything be useful, but I don't think I advertise it that way.
And I think the reason it's so easy to forget is because it becomes so obvious to us, because I know I've structured the class this way very intentionally. Obviously, this lab is to complement these components of the lecture, and it's to give you these experiences. And that's so obvious to me that it's easy to forget that it's not obvious if you aren't me.
Right.
You know? So I think, I have in some places in my lecture notes, I have little reminders, like at the beginning of lecture, I say, explain why you would care to be able to measure the pH about something before we talk about how you measure the pH, you know? And it is funny because sometimes I get to that and I'm like, okay, wait, I do need to reset and make sure I have something to say about that, because I don't have something ready to go in my mind. But if I sit and think for just a second, I'll be able to put some context there.
Yeah. And I think, you know, for me, even the kind of bonus of doing that, or the payoff for doing that, was really immediate.
That's
like
awesome.
It felt like people were like, "Oh, okay, we're doing lab," and I, you know, again, maybe like that's not like a scientific measurement, but it felt better for sure. So I just need to do a better job of conveying that and taking a minute to do that. And I think, again, sometimes, man, what would it be like if some magic teaching fairy came along and was just like, just do half the content this semester and really play around with all of these other cool things. Do you know what I mean? Like, it'd be so cool.
I mean, some departments decide to do that. My undergraduate chemistry department specifically covered less stuff in order to cover more depth. And so that's a choice that the department can make.
Yeah.
The other thing I wanted to mention, you're talking about different places where people might use their physics equation knowledge in the future. My friend works in like software for computers and apps and whatnot, and they were working on software for like swiping on a phone, and they were plugging in the physics equations. And
No way.
they were thinking like, hold on, I don't quite remember the physics equation. They were plugging it in, and they didn't quite get acceleration right. And so instead of like slowing down after you swiped it, it accelerated after you swiped it. And they were like, oh, we got the equation wrong.
I'm writing this down right now.
So anyway, that seemed like a fun example of stuff you can do with physics equations later on.
That's so cool. And again, I'm such a Luddite. Like I'm like, what? Oh, like what? I didn't even think that people would have to do that.
But somebody
sort of
has
thing.
to program how the things move around on the phone screen when you touch them, which
Totally.
I might not have thought of that either had I not heard about programming them wrong.
Right. And yeah, that's like, it's always a good way to get the stuff is the mistakes that happen. We went to a wedding, and somebody at the wedding was like a physics PhD person who worked at Pixar. And
Oh, there
like,
you
that
go.
was their-
Totally.
Yeah. And like and I feel like I just had been moaning and groaning about how am I going to convince people there is physics jobs? But then it's all right there, and I just need to actually say it. You know?
Yeah.
So, yeah.
I wonder if it could be as simple as just putting little reminders. Like when I do have a reminder in my lecture notes to explain the relevance of whatever, it's easy to remember to do it. So maybe just put more of
Yeah.
those in the notes.
That's what I need to, yeah. And I think just taking a minute at the beginning of lab
Yes.
to be like, why do we care
This is
about
why
this
we're
lab?
doing this. This is, yeah. Because, I mean, it is true that out of all possible labs that we could do today, this is the one that we chose to do today. So there's some good reasons and some thought that went into that. So it's
Yeah.
worth conveying. Yeah.
Totally. Cool. So I think I definitely, I don't know. It just reminds me almost of like sometimes when I hear things about self-defense where like if someone said, you're like, yeah, that does, oh, I totally know that, but I didn't know I knew it until you said it, that I should do that thing. And this feels like one of those things where you're like, oh yeah, it's not like, it's not something I didn't know, but it's like just hearing it really crystallized a whole bunch of things for me.
Totally.
So that was super helpful.
Cool. Well, thanks
So-
for introducing this new term and
Yeah, I hope
explicitly
to
thinking
report
about it.
back
Yeah.
about how much I did. And I'm so excited to hear more about your project
Oh,
that you're
thanks.
going to do. That's super
Once
cool.
I develop it more, I'll tell
Yeah.
you about it.
Cool. Okay. Thanks, Claire.
Thanks, Ruth, and thanks, Ralph.
Thanks so much for joining us on the Professor Podcast with Ruth and Claire. We're delighted to have you as a listener, and we would love to hear from you. And if you want to email us, our address is contactprofessorpodcast@gmail.com. We'd love to hear any of your suggestions for future shows or professor quotes that you might want to share with us, or even just things that have come up for you when you were listening to previous episodes. And if you've been enjoying the podcast, we would love if you would spread the word. So the best way to spread word is by telling people if you think they should listen to it, or you can leave us a review wherever you listen to your podcasts. Thanks so much for joining us, and we'll see you next time.